Tunnel design. In this session we shall see the design of bored tunnel. The design is based on the alignment of the center line of the tunnel passing through the center of the tunnel floor of the single-cell tunnel cross-section. The main screen of Heads Pro is opened. We select the working folder Work located on the desktop. Next select File menu option New and then New Open Tunnel Design. As the workspace opens, the current selected tab is Create Project. The project name is Tunnel Design. In this workspace we can do either a new design or we can open a previous design only if it was done earlier with this workspace. Any other project data file cannot be opened to process in this workspace. Next, we select the tab Process Design of Bored Tunnel. The current page is for horizontal alignment. The option Process Halon Design Data is currently selected by default. We click on button Proceed. The design is done and the design report is written in file halonment.rep. Next we click on button View Halon Design for string M001 and to display Shenage and details on the alignment string, we click on buttons Shenage On and Details On. Next, we select Tab Page Vertical Profile to design the vertical profile of the tunnel center line. The selected option Process via Line Design Data. The data is displayed in the left lower part and we click on button Proceed. The design is done and the design report is written in file via alignment.rep. Next, we draw the vertical profile. We display the grid and vertical details along the design string M001. Next, we select Tab Page Cross Section and the current tab page is Define Cross Section to define cross section and create cross sections. The current page is to select tunnel type and define cross section dimensions for various parameters as applicable by following the typical cross section type. We can change values for various items as desired. We may click on button Browse to select the survey data file, and is selected for this tutorial as tunnelsurveydata.txt. We can view the format of this survey data file by going to Tab Page Design Details, then by clicking the button View Survey Data File. This is survey data inside the tunnel after boring for certain length of the tunnel taken by using the robot total station. Tunnel option is being selected as Design and as Built. Next, we select the tab page Create Cross Section, we click on button Process Cross Section Data. The process box comes with list of 2 batch processes in proper sequence. For each process we click on button Proceed to start with the related data as displayed in the lower part of the process box, and as the process is over the message comes informing about the output. We click on button OK, then on Finish. Every time we click on button Yes, to draw the strings after all the processes are over, and finally we click the button Finish located on the right side of the batch process window. The entire design is now displayed on the plan window at the right part of the screen. We click on button Tunnel Cut Quantity. As the process dialog box comes, we click on button Proceed to start. As the process is over, we click on button Finish, and this opens a new window with view of each cross-section and related quantity for design cut, as-built cut, undercut, overcut at the current shennage station as the quantities for previous to current shennage station and as cumulative from the start to current shennage station. We can select a particular shennage to view the result or may use the button Play to see the result at different cross-section with a given time duration. On clicking button Stop, Exit and Finish, we come back to the original project workspace with details with cross-section on left side and a 3D view on the right side. Next, we select Tab Drawings to create project drawings separately for plan, profile, and cross-section. The data is displayed for creating the drawings for plan, profile, and cross-sections. We click on button Process Data in each tab page of plan, profile, and cross-section. As the process starts, we click on button Proceed. As the process is over, the message comes informing about the drawings created by the process. We click on button OK and then on Finish. A set of drawings are thus created as construction drawings. Next, we select tab Design Details, click on button Create Update Project Data File, and message comes about creating updating of the project data file. We can view the contents of the project data file as displayed. The project data file and survey data file can also be opened with Notepad to take hard copy print of the files. We can view the report files created for various design like horizontal alignment, vertical alignment, etc. We can view the drawings as opened with CAD window, and can be saved in desired format compatible to various popular CAD software. Design of tunnel lining. Next, we select tab Page Design of tunnel lining. This design is for the tunnel portal, steel ribs, and reinforced concrete lining inside the tunnel based on structural analysis of the tunnel lining model by applying static load of rock mass, self-weight and seismic forces. The rock loading is based on total resultant rock mass rating, RMR, computed by algebraically adding RMRs for 6 cases. The various tab pages are data input, analysis, design, and drawings for various major steps of the design of tunnel lining. Currently selected tab page is data input, computed RMR, and create data, and we create the analysis input data in text file. We can view the analysis input data file by opening in Notepad. To understand the data, user may visit our website www.techsoftglobal.com and refer to user's manual of our versatile structural engineering and bridge design software Astra Pro. Next, we select tab page analysis, and under this further select the tab page data file, geometry, properties, constants, supports, loading, etc. We can view the tunnel model in the CAD window by using the icon Rotate 3D and moving the mouse over the drawing of the tunnel model. We may click on button Open Analysis Input Data to open the Analysis Input Data file in Notepad. After viewing or taking print, user may close the Notepad. Next, user may click on button Process Analysis. As the dialog box comes, click on button Proceed. The structure, boundary conditions and the load cases are read from the file Analysis Input Data for 6 load cases. Next, to start the analysis, click on button Proceed. As the analysis is over, the message comes about the report file. Click on button OK. The analysis result is displayed in the workspace window for various displacements and forces developed at various node joints, elements, and members of the finite element model of the tunnel, and the worst force will be used for the design of the tunnel. Next, we select the tab Post Process, and further tabs Forces, Load, Deflection, etc. In tab Load Deflection, further click on button Run Forward and this will visually show the magnified deflected shapes at each of 6 load cases. These process utilizes large memory and makes the process very slow in systems of insufficient memory. Next, we select the tab design. The various default data is provided to help the user. We keep the default data without any change and click on button Proceed. As the design is done, the design report is displayed in the workspace. To view the design report, next, we select the tab Drawings. The various structural and reinforcement detail drawings may be displayed either in the workspace for viewing only or in CAD Viewer by using the button Open Tunnel Drawings for editing and saving. The drawings may be saved as DXF or any desired format compatible to various popular CAD software. Coach Profile. Finally, we select the tab Coach Profile. The current tab page is horizontal alignment. The option Process Halen Design Data is being selected by default. We click on button Proceed. As the design dialog box comes, once again click on button Proceed. As the design is done, the message comes. We click on buttons OK and Finish. The design report is written in file halenment.rep. Next we click on button View Halen Design for string M001 and we click on buttons Shenage On and Details On, to display the shenage and details on the alignment string. Next, we select Tab Page Vertical Profile to design the vertical profile of the tunnel center line. The selected option Process via Line Design Data. The data is displayed in the left lower part and we click on button Proceed. As the design dialog box comes, once again click on button Proceed. As the design is done, the message comes. We click on buttons OK and Finish. The design is done and the design report is written in file valignment.rep. Next, we draw the vertical profile. We display the grid and vertical details along the design string M001. Next, we select Tab Page Coach Profile Inputs, to check the lateral clearances between the coach and the tunnel side walls in straight and curved sections. In curved sections, the outer edge or wheel is superlevated by rotating with respect to inner edge or wheel, so there the lateral clearance is more critical and needs to be examined carefully. The various default data is given normally for dual or twin cell tunnels separated by a central wall. The model includes central vertical wall, left and right cells of the tunnel and the coaches at progressive positions moving along the horizontal alignment of the tunnel. We accept the default data and select Tab Process Data. Next, we click on button Process Coach Profile Data. The batch process window comes with a list of 4 processes in proper sequence. Click on button Proceed to start the process. Each process comes and we click on button Proceed. As the process is over, the message comes informing about the output. We click on button OK and then button Finish. As the processing of all the 4 processes are over, we click on button Finish on the right side of the batch process window. The views are displayed and run forward. Any particular shenage can also be selected to view the coach profile there. Any section if with adequate lateral clearance, then decision may have to be taken for modifying the boring or shifting of the horizontal alignment towards the outer edge of a curve. This is the end of the current session for the design of bored tunnel and tunnel lining with verification of coach profile for the designed tunnel. Next, we close the workspace by saving the project data file. Thank you.